I am Mark Donovan, Director of Commercial Applications for Audio-Technica US. I want to go into a little bit more detail today on the DSP that's built into our ATND1061 DAN beamforming ceiling array. There's actually a lot of power in here, and it can be a little bit deceiving when you look at the interface for it, which we're going to do now, but I wanted to explain what each of these elements are and how this is actually very important and can benefit you what's going on inside of here. So this is the page in our software for setting up the ATND1061. This is the audio processing page. Now, as I have said in earlier videos and other videos, that we have actually 6 beams. And today, I've only got one enabled. We just have that one that's on just for simplicity. But you can see that I have these 6 channel strips. Right? So each one of these channel strips relating to one of the 6 beams, and you can see that first one is active. So the first thing you notice is we've got basically a channel strip here for each of those beams. We've got gain, we've got a high pass filter, we even have a 4-band parametric EQ that you can enable or disable. And if you look over here on the right, as I click on that, you can see how you have all that access to those 4 different points on the EQ to be able to control it. You also have, of course, a mute and a fader control. And so all of that data that you have, all that audio that you have right there that you can control. Now, typically this is kind of your split point, if you will. So you can, if you wish, take that data, take that audio from all 6 of those beams and send them out to the DSP of your choice. We've got plugins and modules for everybody from QSys to Symmetrics and a ton of others in between. And quite frankly, it's Dante, so you can take that Dante output to anything if that's what you wish to do. But like I wanted to talk about today, the DSP that's available that's in here is actually very powerful. So the first thing I want to look at over here is over on the right, you have automatic gain control, which I don't have enabled right now. But automatic gain control, of course, that's to try to keep your level at a consistent volume going down, going to the far side, so that they have a consistent level going into their echo canceller. That's really the key there. That's what it's there for. And you have the ability to select a plus or minus target to keep that level where you want it to be. You also have an automatic mixer. Now, this is a gain sharing automatic mixer, which is to say that you're trying to achieve a specific target output level, and the microphone is going to automatically adjust the levels on the different active channels to maintain that target level. Now, that makes it very easy for gain sharing auto mixer, but that can be difficult if you have somebody, for example, let's just say that you're doing a classroom situation. You have the instructor, you have this also ability to pick up students out there. What if you need to make sure that on the far end, the instructor's voice is more present, has a little bit more volume than anyone else? And that's what these little sliders up here are underneath the weight. It's the weight control for that channel. You can apply more weight or more of the share of that output gain to a specific channel. That way, even if other students are talking when the instructor speaks up, they're going to be more present, louder on the other end. So this is actually a very powerful mixer that's built into it. Now, you also have in here some noise cancellation. And noise cancellation, in this case, is very important, actually in any case, is very important in making sure you have clean signal-to-noise ratio, especially on the far end for their echo cancellers. And noise cancellers like this are intended to get rid of steady-state noises. And what this does, in this particular case, it's really adept at handling noises like fans, projector fans, air handler sounds, noises, the steady hisses and things like that are in the room, to get that noise floor down so that you have that good signal to noise ratio. And you can set the amount of attenuation on there actually from 0, which of course is off, all the way up to plus 20 dB with cancellation of that noise. So you have a lot of control there, the ability to really, dial out that noise that might be causing you some problems, some intelligibility issues. And then finally on here in this processing, we have the AEC, your echo canceller. So that's built into this device. Now, it's a little deceiving when you look at this because there are very few controls on this, but it's actually very powerful AEC that's built underneath this. It actually has a tail of 400 milliseconds on it, which is a very long tail and is a good size for processing. What that means The tail for processing is the time in which it's able to process echoes within a space. To put it in real simple terms, the higher that number, that tail length number, the larger space, the more reverberant space that you're going to be able to deal with and effectively cancel the echoes. So this can handle some very large size rooms. Now, this DSP, like I said, is all built into this. Now, I don't know whether you noticed this or not, but when I was on automix, there's a little setting over here with a drop down. It says standalone or link. And what you do here is this is when you have more than one. And if we go back to that classroom application, many classrooms are a little larger, and even though this mic can cover that 5-meter radius, pretty big area, you may need 2 or you may need 4 of them in this space. Well, in the standalone and link mode, you can effectively set up these microphones in the ceiling as a distributed DSP, where each of them is doing their own internal DSP processing, but then they are linked together. So the link here is going to logically link the automatic mixing between the devices, and then actually in Dante controller you're going to do some routing between the different devices so that effectively your path, your audio path, looks a little bit like this. You bring your echo reference up, which is the audio coming from the far side, to the first device. The first device then shares that audio to all the other ones, and they each do their processing. Once they've done that processing, they route their audio all back to the first device where it's combined to a single auto-mixed output. Now, earlier I said you could take these beams out and you could process them in whatever DSP you'd like, but if I'm using 6 beams on each microphone, in the case of 4 microphones, that's 24 channels of Dante. And that's going to put you into a certain price point when you're talking about an external DSP. Those channels of Dante get expensive. But if you use the DSP that's internal, I'm only using 1 Dante channel to go up to the mic and 1 Dante channel back down from it with that full auto mix. So this can really make not only a less expensive option, it certainly can save you money that you can turn back into the job with something else, but it also makes it considerably easier, much simpler application. So the DSP that's built inside of it is one of those hidden gem kind of things. It's really a lot to it. I think that that makes this a much more powerful device than it may seem on the surface. So that's just a little bit of a dive into there on the DSP and the ATND1061. Thank you.